So I'll go ahead and log in as the IAM user. I'll key in my password. When you log into the AWS console, the first thing that you want to do is select the region where you want to launch your resources. For this, I'm going to change this from Tokyo, which is in AP Northeast 1. I'm going to go all the way to North Virginia. This is usually the default region, but I chose it because it is the oldest region really, as compared to other regions. So probably it has more resources that we need, but make sure you launch your application nearest to where your users are, okay? Nice. So we go to US East North Virginia. So you can see here, the region has changed to North Virginia. So I'll bring up my apps.diagram. So if you guys want to know where to get this, just go and search for apps.diagrams.net. This was previously known as Draw.io. It will bring you to the same results. So here, I need to search for a shape. So I need to search for a region. I'll look at these icons. Let me go with this. Okay, this is our AWS region that we want to launch our resources. I'll drag this aside and continue with the demonstration. So the first thing, we need to create a VPC and specify where it will be located, that is the availability zones, and create our subnets. Without further ado, I'll come here to the search bar and search for VPC and right click and open in a new tab. So here you see that there are one VPC. So this is the default VPC Amazon. We want to create ours, so I'll click on create VPC, choose VPC and more. This will allow you to get a preview of what you're going to create. If you choose VPC only, you will not get the preview. Okay, so I'll choose VPC and more. For the project, I want to call this project details all. After I have input the name, so this is where you put in the name tag. The preview section will automatically prefix it with a /VPC, or maybe it will prefix it with a -VPC. So we need to set our IPv4 header block. I'll leave it as default. We don't want to use any IPv6, so I'll leave it as. For the tenancy, there are two types. If you click here, and you'll see that there's the dedicated and the default one. I'll choose default. Now, since we want app to be shifting from one availability zone to the next, I'll make sure that the number of availability zones is 2 or more. For our demonstration, we'll just go with 2. The number of public subnets, this is where your web server will reside. So I'll choose 2 so that they can be load balancing every other time someone requests access. For the private subnets, because now we're not launching any resources in the private subnets, I will not be creating any, so I'll choose 0. For the NAT gateways, we don't have any resources in the private subnets, so I'll choose none. So VPC endpoints can help reduce NAT gateway charges and improve security by accessing S3 directly from the VPC. So this I'll leave it as default. Then I'll leave this enabled, the DNS hostname in the resolution. So when you scroll to the side, you'll notice that since we added a public subnet, our VPC was automatically attached to an internet gateway through this public route table. So notice that when I remove the public subnets and scroll all the way, I can't find any route tables connected. So I'll just go ahead and put 2 public subnets. And then after I finish doing all that, I'll just come here and click on create VPC. So your VPC is created, and here's a success message to confirm that. These are some of the resources that have been able to be created. So I'll click down here to view my VPC. As you can see, the state is available. I'll go ahead and do more configurations. Okay, so on the VPC dashboard, scroll down until you can see subnets. So we want to edit these subnets. If you click on some arrow that appears here, this one, it will open in a new tab. When you check this subnet keenly, this public US East 1A, you will notice that auto assign public IPv4 address is set to no. So we're going to change that. Hover all the way up to the Actions tab, click on it and edit subnet settings, and make sure that you've enabled auto-assigning IPv4 addresses. Scroll all the way down and save changes. You notice that you have successfully changed the subnet settings, and if you scroll down, you will notice that the auto-assign public IPv4 address is set to yes. So we're going to do the same for the other subnet. I'll click on the other subnet. It opens in a new tab, and then you will notice the same thing. So I'll click on Actions, Edit Subnet Settings, and enable auto-assign IPv4 address and save. Once this is set to yes, you're going to go. So the next thing that we'll do, we'll create a security group for our VPC. So on your VPC dashboard, scroll down on the left pane up to where you will get something related to security groups under security, opening it in a new tab. So here we need to create a security group, allows traffic on ports 80 and 22. Click here to create a security group. Security group, I'll just call it HTTP SSH security. Description, I'll say allow HTTP and SSH traffic. For the VPC, I'll clear this and choose details of VPC. For the inbound rules, you need to add a rule and select HTTP first. So HTTP is the one I told you, it's port 80. And then for the source, select anywhere IPv4. We want it to come from the internet. This is anywhere from the internet. Add another rule and call this one SSH. So this is the port for SSHing. We'll be SSHing into our machine in order for us to install stress so that we can test whether our autoscaling really works. So I'll be SSHing from anywhere. Typically, this setting, in order for you to achieve more security, you need to set it to be a certain range of IP addresses. So you need to specify it to only be accessed through SSH via certain IP addresses, whether it's the IP addresses of a certain company that you want to allow access to your instances. You just select custom and select the range of IP addresses. But for this demonstration, I'll only be using anywhere IPv4. That's it. When all that is done, scroll all the way down and click on Create Security Group. So our security group has been created successfully. This is the security group name and this is the security group ID. So from the security groups, we need to create our target groups. So our target groups are located under EC2. So I'll just come and type EC2, open it in a new tab. On this left pane, scroll all the way down where you will get to target groups, open in a new tab. So here we need to create a target group. For the target type, I'll leave it as default instance. We need to target instances. Target group name, I'll just call it test or target. For the protocol, I'll leave it as port 80. Then for the VPC, I'll choose details or VPC. Leave all the other settings as default. Click next. In the next pane, where they ask you to register for target, do not register any targets. Scroll all the way down to target group. Now I'll bring up the diagram we were drawing before. So what we've been able to achieve is to build a VPC. I'll search for VPC. So this is the icon I want to use for the VPC. The VPC is inside the region. And on this VPC, we have availability zones. So this is one of the availability zones. I'll copy this and paste it. And this is another availability zone. We saw that our VPC was attached to an internet gateway after we specified that we needed a public subnet. So an internet gateway will come in here on the VPC. And then since the internet gateway came with a public subnet, we'll go to add a public subnet here too. So this is what we have for now. I'll go ahead and walk you guys through creating the rest of the resources. We already have our target group. Now on the EC2 dashboard, scroll all the way down up to where you will get to see load balancers. So we need to configure load balancers. I'll click on load balancer and open it in a new tab. See, we have no load balancers. So I'll click here to create the load balancer. We want to choose the application load balancer. So I'll scroll down and choose create. For the load balancer name, I'll just call it Vitessol load balancer. For the scheme, our load balancer is internet facing. So this is because we are launching our resources in the public subnet. If you had private subnet targets, you would use internal load balancer. For the IP address type, I'll leave it as IPv4. If you wanted to include IPv6, you would choose dual stack for both IPv4 and 6. Here on the network mapping, I'll choose Ditesol VPC. Then I'll select both the availability zones. On the security groups, I need to select from the drop-down the security group that I created. So I'll click on this X to cancel this security group. Click on the drop-down and select the security group that we created earlier on. This is the security group we created earlier on. Okay, for the listeners and routing, we want a listener on port 80, that is the HTTP, and then the default action will be to forward the traffic to a selected target group. So you remember we created a target group, so here is where we will select the target group. We named it as Ditesol targets. Leave all the other options as default. In case you wanted to add AWS Global Accelerator, you will just check this for you to improve performance and availability of your applications. If you needed any tags, you have to specify any tags here. And below is a summary of what I've just done. And without further ado, I'll just click on Create Load Balancer. So I have successfully created my load balancer, which is called Ditesol Load Balancer. I'll click here to view my load balancer. So it's in a provisioning state. We'll give it time. So as my load balancer is provisioning, I'm going to look for launch templates here. Then I'll open it in a new tab. So we need to create a launch template. For the launch template name, we put it at Ditesol launch. Template version is they give you a sample description of what name your template. I'll just call it a test server for my app. I'll scroll all the way to launch template contents and choose the application operating system image. And this I'll be using Amazon Linux 2. For the instance type, I'll choose T2 Micro. Then I'll create a new key pair for logging in. The key pair name, I'll call it Ditesol key pair. Then create key pair. Here will be downloaded to your local machine. At the same time inserted here on the key pair name. The network settings, I don't want to include a subnet. So I'll choose an existing security group. And from the security group drop down, I'll choose the security group we created there before, HTTP SSH security. I'll leave the rest of the settings as default. Now we need to scroll all the way to the advanced details section. This is where we want to specify our user data. So on the user data, I'll just paste in a script here to install a web server on all these EC2s that will be launching. Basically, this is a code. This is a user data on the user data part that installs the web server, and it displays this word whenever you try to search it from a browser. So basically, it will tell you "Hello World" from. This is a placeholder for hostname. So it will pick the hostname of your machine and it will display it to you. So whenever you refresh, you'll get that the hostname keeps on changing. This will be successfully evident that load balancing is working. So yeah, let's go ahead and create our launch template. Successfully created Ditesol launch. Click here to view launch templates. We'll go back to our load balancer, try to refresh. So you can see our load balancer is now active and we have our launch template. So I'll go back to the diagram we were drawing, add a load balancer. We've created a load balancer. So the load balancer we have is an application load balancer. I'll minimize it a bit somewhere here. And now what's next? We need to create an autoscaling group. And for me to do that, on the EC2 dashboard, just scroll all the way down until I meet autoscaling group. This is where I want to typically select. So I'll open it in a new tab. And create an autoscaling group. For the autoscaling group name, I'll just call it Autoscaling Autoscaling Group. Then for the launch template, you must select a launch template that we created earlier on, one we call Dataset. It will bring up details of your launch template. Confirm these are the details and click next. So for the network part, for the VPC, I'll choose the VPC created earlier on and the availability zones we allocated it. So this is all VPC or the availability zone, and then click next. Okay, on the load balancing, I will attach to an existing load balancer. You remember we created a load balancer? So I'll attach it to an existing load balancer. So here, I'll choose one from my target groups. So I'll select a target group that we created, all targets. Health checks, I'll leave it at the default 5 minutes. This is 5 minutes, then click next. So this group size, desired capacity, this is the number of instances that you want to always be running. I'll put this at 2. For the minimum capacity, this is the number of instances that you want running whenever all the instances have been died or maybe have become faulty. I'll put it as 2 as well. And for the maximum capacity, because there's too much load, this is the maximum number of instances that you want running. I'll put it as 5. Now here on the scaling policies, I need to choose a target tracking scaling policy. For the name, I'll leave it at default. Metric type, I'll have to use average CPU utilization because ideally, I want whenever my CPU usage goes above some point, then there will be a policy to initiate more CPUs from the launch templates. So there are more metric types that you can use, but we'll go with the CPU utilization for this demonstration. I want the target value to be 20 for the CPU utilization, and then this is the duration in seconds for the warm-up before including in metric. So the new instance that has been launched, will give it 60 seconds to warm up before it can start showing in metrics. Then click on next. If you want to add notifications for you to get notified whenever an EC2 has been launched or terminated, you can enable this. I'll skip this for now, so I'll click next. You can add additional tags if you want. Click next. Now here is where you get to review all your choices. For the network, it's okay. For the instance type requirements, it will get to the launch template. The load balancer is the one I chose. Make sure all these details are correct. Then click on create an autoscaling group. So you see that Vitosol autoscaling group has now been created successfully with one autoscaling policy. And as you can see, there are no instances now running, it's updating capacity. So if I refresh here, you will see that 2 instances have been launched. So if I get to open my instances in a new tab, you find out that 2 instances are currently running. If I refresh, as the instances are initializing, you will notice here that the availability zones are now 2. US is 1 A and B. So one instance is in A and another instance is in B. So as we're waiting for them to initialize, I'll just bring up my diagram once more. So here we need to edit this availability zone. Maybe let's call it US 1A. This one US 1B. And now you can remember that we have our auto-scaling group. So I'll search here for an auto-scaling group. I'll search scaling. This is what brings up the auto-scaling. So we need an auto-scaling group. This one will be somewhere here. So in this auto-scaling group, we have EC2s. For now, we only have 2 EC2s. And that's the diagram for now. We'll go back to check on our instances, try to refresh. You can see 3 instances have been launched. We now have 2 in US East 1A. Okay, for you to test the reachability of the instances that you've just created, go to your tab where you have the load balancers. And on the load balancers, select the load balancer we just created. Copy the DNS name. So just click here to copy it. And then open incognito window. You need to visit this website to see whether it can load. As you can see, it has loaded. And what is it saying? Saying hello world from IP.87, right? So if I come here and refresh once more, you'll find out that the IP has changed to 77. If I refresh once more, the IP will change to 25.204. So refresh once again, come back to see now there are three instances that are running. Tested that the load balancing is working. Now we want to test auto-scaling. In order for us to test auto-scaling, we'll go back to our instances, refresh. So we need to simulate some stress on one of our instances so that we can see the scaling activity in real time. So I'll SSH in one of these instances. I'll select one, and I was waiting for my virtual Ubuntu machine to open so that we can SSH into one of the instances. I'll bring up the diagram once more to show you guys what just happened. As incognito users, what we've been able to do is access the website through the internet gateway, and then the internet gateway was able to push the load to the application load balancer. The application load balancer was able to communicate with the autoscaling group and get to inform them of which EC2 to use. So as you notice, we have two instances in US 1A, so I'm going to include them. Yeah, and that's how the users were able to communicate to the web server that's being hosted here on EC2. So I've been able to download the clip here on my Ubuntu machine. So I'll just CD into download. Then I'll change the mode of details or keep pair to executable. Then I'll SSH using the key pair as the EC2 user. Then I'll copy the IPv4 addresses, the public for the one that I want to SSH into. Then I'll type yes. And there you go, you're into the machine. Once you're logged into one of the EC2 instances, and like as you can see, this is the EC2 instance that we just logged into, the one 204. So we need to install extra packages for enterprise Linux. So I'll paste in this command down here. So it's sudo amazon linux extras install y. So now that our extra packages for enterprise Linux have been installed, we need to install the stress package. That's the code to install the stress package. And from the results down here, you can see stress has been installed and has completed the process. So I'll clear to have a better screen view. So we need to stress the CPU. We need to stress this CPU by 8 more CPUs. So I'll add 8 CPUs and I'll need the timeout to be 300 seconds. I want it to stop after 300 seconds. So if I press enter now, we expect it to spin up more instances. Yeah, press enter. As you can see, it's dispatching the stress in for his 8 CPUs. We want to dispatch 8 CPUs. So in a moment here, you'll start seeing CPUs sprout up from nowhere. I mean, instances sprouting up from anywhere. So I'll keep both of these open so that you can watch them as they spin up. Surprisingly enough, you can view the CPU metrics of all the instances. You just need to select them all, maximize. As you can see, the one with blue has started increasing because this is the one that we've added load to. So I'm gonna set this to 30 minutes so that I can see more granularity and keep refreshing. Meanwhile, stress is still being applied on the machine that we just chose. It's gonna take some time to refresh. Now, after some time, you will notice that the stress for this instance has increased all the way to 70% mark. Yeah. So now we expect new instances to be launching. Okay, we're going to duplicate this tab so that we can have those tabs online. As you can see now, some instances have started being spun. We have this one that's pending, and we have another one that is pending. We have 3 instances that have been launched due to that scaling event. Still pending. Okay, they have started running. 5 instances are running, so they are still initializing. If you go back to monitoring that we had, you will notice that these other 2, one in green and yellow, are still having a low CPU utilization. We didn't install stress on them as compared to the first one. So I'll go back to the instances to see whether they have been initialized. They're still initializing. So it's been a couple of minutes now, and all the instances have passed status checks. So I want to monitor all in one dashboard. So I'll select them all, and then I'll enlarge this on set custom so that I can use with some granularity. As you can see, now the stress has successfully been completed, the stress run. So we can now see that the instance that we had installed stress has now started going down. We should expect instances to start being terminated. Let's just refresh here. They're still running. So after some time, we'll expect that the instances will be automatically deleted. You see the CPU utilization for the instance that we installed stress on is still going down. So as we're waiting for it to delete all those instances, we'll go back to the diagram we were drawing. This is the diagram. So we saw that 3 instances were launched in East 1A, this copy and paste another, and 2 were in B. So basically, this is the number of instances that were launched during the system load increase, and this has confirmed that our autoscaling is working. Now you can see that the traffic has gone all the way down for all instances, even the one that we've launched recently and the ones that were there before. So we will wait for it to automatically delete the additional instances. So the instances will stay on a while. You remember that we set our health check interval to be 5 minutes. So after 5 minutes, they will check the health of all instances. And if it's below 20, they'll start deleting the extra instances. So let's just wait. If we hover back to our scaling group, that's the instances that are running at 5. And that's the status is in updating capacity, because we decided to have only 3. So we expect that only 3 will be running because we have not achieved the 20% utilization threshold. Yeah. So we'll keep on refreshing and looking at the instances. So after some time, you'll notice that instances have started being shut down. So some instances are terminated by the autoscaling group, and we are back with our 3 instances. You can see only 3 are running. So I'll come and update the diagram we had. We only have 3 now. So with A, I guess, and Y and B. And that's it for the autoscaling. I'm going to name this auto so this is it. This is what you should have had. I'll be sharing this to you guys, so don't worry about taking screenshots and stuff. So basically, if you want to edit and maybe remove the grid, just go and view and select grid. So that's the image, that's the architecture for what we just built. So I'll go ahead and clear all these resources. The purpose that I had all these tabs open is because I'll go to each tab looking for resources that I launched on each tab and submitting them. That's it, guys. Thank you for watching. See you in the next.